Okay, in this session, we are going to learn about the basic concepts in database systems. Okay, so I'll just write down the heading here. That's Introduction to Database Systems. So, before we begin, let's just understand what do we mean by data. As per the definition of data, data is something which represents a fact and has some inherent meaning. Okay, so we are talking about a fact and some inherent meaning. To make this distinction very clear, let us take an example. I'll give you some information, okay? Let the information be Jimmy, 15, Tommy, Poodle. Now, do you think that this information represents a data? So let's ask a question. Does it represent a fact? Well, I can get no fact from this. Does it have any inherent meaning? Don't think so, right? So we can realize that this information is not data. Now what would I need to make this a data? Let's suppose I tell you that this value is name of a person, this value is age of a person, this value is the name of the pet of the person, and this value is the breed of the pet. Now, do we have some inherent meaning? Obviously we have some meaning. The meaning is that this poodle is the breed of the pet, this Tommy is the name of the pet, this 15 is the age of the person, and this thing is the name of the person. Okay? And does it represent a fact? Well, sure well represents a fact, because now we can say that Jimmy is the 15-year-old person who has a pet poodle named Tommy, right? So that's about data. It should have an inherent meaning. It should represent a fact. So now I think we're pretty clear about what data is. Now we will look at what a database is. Okay? We're done with data, and now we'll see what we mean by a database. Database is pretty simple. It is just a collection of related data. Okay? The data has to be related. So let's take an example to find out what exactly database means. Let's I tell you that we have some collection of data regarding the names of persons, and their details, and we have some collection of data regarding, say, number of car brands, and we have, say, a collection of data regarding four-legged animals in this world. And we also have a collection of data regarding all the trees in this world which are greater than 50 meters in height. Okay? Now, can I call this collection a database? Is it a database? Let's look at our definition. We said that database is a collection and it is a collection of related data. Okay? So can we somehow relate these things? Do we have any idea what this means? We can probably relate this. The person owns a particular car brand, but what about this? We don't have much relation, right? And what about persons and trees? It really doesn't make any sense. So you would rather say that this collection is not a database. Okay? So let's see what is a database. For that, we will take a look at another collection, and this collection is details of person, okay, then it is details of cars, then it is details of offices, okay. Let's take one more collection, which is the details of locations. Now we'll take a look at this collection and try to see if we can say that this is a database. Okay, let's find some interrelationship between these set of data. You can say that these set of persons use these set of cars to go to these set of offices which are in these set of locations. Okay, so we have somehow devised an interrelationship among these set of data. So we can pretty well say that this is a database. Let's look at properties of database. We've already taken a look at what database means, okay? So now we'll see what are the properties of database, of any database are. The first property is a database represents some information about some real world or a part of real world, okay? It represents information regarding a part of real world which is called the mini world. Okay, it models a mini world. This mini world is also called as universe of discourse. So, for our database, this mini world is the universe, right? Universe of discourse. So, what is the mini world in our case? In our case, the mini world is the people who go to their offices on a particular car to a certain location. So this is the mini world that you're trying to model over here, okay? So that's the first property. The second property is the collection of the data is interdependent. Random data about random things doesn't constitute a database. So obviously we've already taken a look at the interdependence. We have found the interdependence on the basis of which we have classified this collection as database. So we won't waste more time here. And the last property is every database is built for specific reason. Every database is built for a specific reason for specific users. Okay? So in our case, the users of this database could be the set of people who are wanting to know the details about people who use cars to go to their workplaces, or probably details about how far do people go in their cars to their workplaces, or details about how far their workplaces are from their homes, and all kind of such related details regarding cars and using cars to workplaces. Okay, so the properties of database would be it maps a real world, it models a real world, the collection of database, or rather the collection of data that it has is interdependent, and the third is it is built for specific reason for specific users. And now let's look at what a database management system is. Okay, database management system. A database management system is a collection of programs that allows me to create and maintain my database. It's as simple as that. Okay. DBMS is a set of programs which help me create a database and maintain the database. Now let's look at what are the functions and operations that are performed in a database. So, functions of database, or rather DBMS, database management system. The first function is it helps me create the database, or rather define the database. When I say define the database, it basically means it helps me model the mini world into my database. It gives me constructs, language tools, so that I can create data searches in which the values can fit in. I can create constraints which map to the real world constraints in the world. For example, I can say that assume I'm modeling a database which is describing the relationship of two or more people in terms of marriage relationships or dating relationships and such stuff. So when I say that two people are married, I can define a constraint in the database that if it's a boy, he has to be greater than 21 years of age. Or if it's a girl, then at the time of the marriage, she has to be greater than 18 years of age. So such kind of constraints can be defined in the database, and the DBMS allows me to enforce these constraints. Okay? Now, the second function of the database is construction of the database. Construction. Once I've defined the database, once I've specified the basic structure of my database, I would like to fill those structures with some values. DBMS allows me to source the values into the database from, it could be from a manual input, it could be from some other files in which probably there is already some wealth of information and we want to convert those information from the file system into the database system, right? Or there can be any other source from which we want to fill the database up with. Okay. Next function is it allows me to manipulate the data. What do I mean by manipulate the data? It basically means that a person can easily find information from the database. He can make queries to the database, which means he can ask questions. For example, let's suppose we want to know all the set of people who were married on 21st of July 1980. So the database would give me the results of all the people who were married on this particular date. Okay? Or I want to know all the people who married at the age of 23. So that kind of information I can have from the database system, and it helps me in finding out that kind of information. The other part of manipulation is it helps me to change values as the manual changes, okay? So obviously, if we have marriages, we'll probably have divorces too, right? So I need to change the status of that marriage to divorced, okay? Now, if I say Mr. X is married to Mrs. Y, and after some time they are divorced, I should have some mechanism to store this information into the database, which basically means that I should be able to change that information that they are married, okay? Because they are not right now. So it helps me manipulate and change the values of the items that are already stored in the database. The next function is it helps in sharing of data. We already talked about how it helps me in asking questions and gathering information. But despite this help, if I'm able to use this database only 1% at a time, then it's really a constraint, right? Ideally, many people should be able to access this information at the same time, and the database helps me in doing so, despite having any kind of catastrophic effect on the database, okay? For example, if 2 or more people want to change the value of a particular data item at the same time, then it can have some catastrophic results, and we don't want that to happen, and DBMS helps me there. The next function is protection of data. Obviously, whatever I'm storing, I want that is stored forever, okay? I want that nothing should happen to that data. It should not get corrupted. Even if there is an earthquake, I should have some mechanism so that I can have my data back, right? So DBMS allows me to back up the data. It has log-based recovery systems, which basically help me recover from system crashes and failures. And it has a host of other features which basically protects my data. Okay, now we will take a look at the systems we had before we had this database management system concept, okay? So basically we are looking at file-based database systems. I'll write it down for you. File-based database systems. Also called as file processing based systems. Okay? So we process the files to retrieve our information from the database. Let's just take a look at what these actually are, okay? So, in these systems, what we have is a set of files, okay? We'll have file 1, we'll have another file, we'll have another file. So let's say this is a database of employees of a particular company. So what we would have in this database, or in this file-based system, we would have a file of employee details. Okay? Then we'll have a file of, say, employee salary details. It's going to have probably salary, bonuses, stock options, and so on and so forth. And then we will probably have employee department details. This is going to store the information regarding which employee is working in which department. Okay? So we have 3 files. Now, whenever I need to find some information, what I'm going to do is I'm going to ask a programmer. This guy is a programmer. Now this programmer writes an application program. And this program reads one of these files, or probably more than one of these files, to find the information. So suppose I need to find the employees who have salary, say, greater than 50,000, okay? This could be anything, 50,000 rupees, $50,000, whatever. So for my query, which says I want all the employees having salary greater than 50,000, what's going to happen is this programmer is going to write a new application program which is going to read these 2 files, and he's going to find out the details for me, okay? So now if suddenly my query changes and it becomes employees working in maintenance department, okay, then what would happen is this guy is going to write a new application program, okay, and he is going to get details from this file and from this file and give out the details to me. So that's a problem, you know. Every time a new query is required to be entertained, then this programmer guy has to write a new program. So what this programmer guy does is he realizes that most of his queries are of these 2 types: salary greater than X, or employee working in Y. Okay? So what this programmer does is he creates a new file. And this file basically has the details of the employee and his salary. And this file has the detail of employee and his department. Okay, so now the next time someone asks this programmer guy to find salary greater than 80,000, he just has to read this particular file in this program. Okay, I would rather create it like this. He has to write a new program which reads only one file. Okay, so this way his job has become easier. But now we have a problem. The problem is salary detail are duplicated. Salary details are duplicated in two files. Okay, so if suddenly employee X is given a raise and his salary is increased from 50,000 to 80,000, it now becomes imperative that our programmer guy updates both of these two files, this file as well as this file. Okay, so that's basically major problem with these file processing based systems, and that's basically the gist of file processing based systems, how they work. Now we'll see why we actually needed a database management system. Why wasn't a file-based system enough? Okay, so for that, we are now going to take a look at disadvantages of file-based systems. Okay, disadvantages of file-based systems. So let's start. The first problem is data redundancy. Redundancy, okay, the spelling I hope is correct. Data redundancy basically tells me that the salary data is being replicated, or rather duplicated, in two files. So whenever I have to make an update, whenever I have to make some changes, I need to do that in both of these files. If somehow I just forget to make an update in the main file and I just do an update only in this, because most of the times I'm working with only this file, okay? So there is a major problem if I'm going to do that. What's going to happen is there would be two sets of values which would indicate two things to me. This file would probably tell me that worker X is getting 80,000 salary, while this file is going to tell me that worker X is getting 50,000 salary. Okay, so that's a problem. So that's a disadvantage with this type of systems. The second problem is data access problem. Data access problem. Obviously, every time a new query is to be fired, this database guy has to create a new program. This program is going to read 2, 3, 4 different files and do some computations and show me the results. So that's very laborious process. That's not befitting under all circumstances. For different type of people, there should be something that's very easier, and something probably having interfaces, so that probably having menus, so that we can easily find the information that we want. Okay, so that's the second disadvantage. The third disadvantage is integrity constraints. Integrity constraints. As already mentioned, integrity constraints are the constraints that we basically or normally have on our real world systems. So as I mentioned, we have a constraint that every boy who's getting married is at least 21 years of age. So if we have this constraint in the database, or rather if you want to model this constraint in the database, what we would like to have is a program which is going to model this constraint. Program modeling the constraint. So every time a new value is entered into the file-based system, what's going to happen is a program is going to verify that the person getting married is greater than 21 years of age if he's male, or rather if he's not, then probably he's going to throw a pop-up saying that you cannot enter this value into the database and something like that. So that constraint in a file processing based system is modeled via an application program, and for every new constraint that we have to write a new application program or probably add a module into the application program. Okay. Number 4 problem is the data isolation problem. Data isolation basically means that I should be having my data in a centralized module, a centralized module. My data should not be scattered in different files, having different formats, having different ownerships, okay? So as we studied here, in this case, my data is basically scattered in around 3 files, and probably will have different owners for these 3 files. So there is lots of problem, okay? So I want my data to be centralized. This is not possible obviously in file-based systems because users randomly create new files to suit their needs, as we saw in the previous example. Database programmer or application programmer created a new file to suit his need, where he wanted to save accessing 2 different files. He just created a new file so that he could access just one file and get the query that most of the people wanted to get from him. Okay. Next thing is atomicity problem. Atomicity basically indicates, it's a concept related to transactions. Okay, transaction is something, it's like a logical single unit of work. So assume let's say you're buying something over the net, buying over internet, okay? So in that case, what's going to happen is the transaction would be comprising of 2 steps. In the first step, money transfer would take place. You're going to give some money to the merchant from your buying a particular good. And in the second stage, what's going to happen is that merchant is going to update his database saying that the good or item now belongs to you. Okay? Now belongs to you basically means he is going to decrease his inventory by 1 and going to ship it to you, or he's just going to decrease it by 1 and he'll ask you to collect the item. Anything of that sort that basically symbolizes that you have purchased the item. Okay. So now let's suppose a scenario where these 2 steps are happening, but after the first step, say after the money has been transferred from your account to the merchant's account, the system crashes. The server at the merchant's end crashes. What's going to happen? The money has been transferred to that person, but the good has still not reached you or has still not changed its status that it belongs to you. Okay? So that's a problem, right? So these kind of problems cannot be dealt with in file processing based systems. So that's a disadvantage. The next thing that we have is concurrent access anomalies. Concurrent access problems. Concurrent access basically means, as we have talked about in DBMS systems, we told that it allows sharing of data, which basically means more than one person can at any particular point in time access and retrieve and manipulate a particular set of data item. So concurrent access problem basically says that, let's suppose a scenario where I have supply of a particular item, supply of X is equal to 1, okay? It basically means there is only one item of type X. Say it's a very posh collectible version of a Swiss watch, okay? And we have only one piece left. And two people at the same time log into the system and buy this particular watch. There are two guys who do this. He buys it and he also buys it. They do this at the same time. So what's going to happen is, at the database end, the program is going to find that still there is one piece left, and since this is happening concurrently, both of these guys see that there is one piece left and they buy it, okay? But since there is only one piece left, only single person can buy this watch. However, since we are allowing concurrent access, this kind of scenario has cropped up where we cannot basically differentiate when two or more people are trying to access the same data item. It's gonna have problems, okay? If say only this person is able to buy this watch, then this person is going to crib, because they both tried to do the access at the same time. So that's a problem, concurrent access problem in file-based systems. The next issue is security issue. Obviously, as we saw, there are many different files, many different owners. A person is able to create his own version of the file. So there is no security, okay? Any person can probably access a file, can make updations, and you don't know what's happening. So that's a problem. That's a security issue that's not properly handled in a file-based systems, okay? We basically want that a component database that is being accessed, that should be accessed only by a person who is related to that component, who has something to do with that, okay? So a PM should not be able to see how much a manager is taking home as salary, okay? He has no business in doing that. So that kind of access we should be able to provide. File-based systems, they are not able to provide it. Obviously, if they are able to provide it, you have to write complex programs for that to happen. It's difficult to scale.